Hai, Assalamualaikum warahmatullahi wabarakatuh. And today I want to show you how to for I am from group 10, flat 10. And here is part A for the lab. Can if you look at here, and I already simulate or construct the circuit. I show you. And here for I use to R2 become for ohm 400 ohm, and here is the value of V in and V out. So we can look at here is V in equal to 10 is a maintain, and V out will be the 5 volt. Is a depends on the R2 value, and also the value that when the R2 change, the value of V out also change. And we move forward for part B. For part B, we already add the parameter sweep, and the difference between with parameter sweep and non-parameter sweep is, first thing first, we need to know the meaning of the parameter sweep. The parameter sweep is allow for parameter to be sweep or through a range of value and can be performed when running a transient AC or DC sweep. So we can conclude that when we have a parameter sweep, we have a long range that needed, such as I give you some example. This parameter sweep, when we edit for property, sim equal to DC1 is depends on the DC simulation here, and the param become RR, which means the value that will be come out will based on the R here, and it become 0 to 1000. It will be the value of R out from 0 to 1000. And here you can look the value of V out here. When the R become 100 ohm, the value of V out will be 2 volt. That's all from me. Thank you.
Hi, my name is Muhammad Fahmi Birosli. Now we at part C in AC circuit measurement. I will explain about AC simulation sweep and without sweep. So we have here AC simulation without sweep, and down here we have a simulation with sweep. According to lab sheet part C, the student required to construct the circuit as in the figure 3 as circuit below. Then we have setting for AC simulation. We start from 50 Hz and stop at 100 Hz with 0.6. The parameter sweep down here, parameter sweep allow for parameter to be swept through a range of value and can be performed when running a transient AC or DC sweep analysis. Parameter that can be varied include a voltage or current source, temperature, a global parameter or a model parameter. So now we move on to the result for AC simulation without sweep. We have here 50 ohm, 100 ohm, 150 ohm and 200 ohm. So for the result for 50 ohm, we have here because of its AC simulation, we have positive and negative. So for 50 ohm, we have peak with 48 volt and negative peak with negative 4.8 volt. And for 100 ohm, it's similar to 50 ohm but with different volt, which is 2.4 and negative 2.4. Similar with 150 ohm and 200 ohm, it has 1.6, negative 1.6 and 1.2 and negative 1.2. So we move on to AC simulation with sweep. For AC simulation with sweep, we have a little bit different than without sweep. This because we don't have to change resistance value each time. This is because once we simulate the result, we get all the possible resistance value for resistance R out. This is because once we simulate the result, the circuit we have in tabular table we have R out 50, 100, 150 and 200. It is similar result for AC without sweep. The different AC sweep and without sweep, the different AC without sweep is not that much different. It's because AC sweep will much easier than without sweep because it will combine all the possible R out, and it's similar to DC sweep and without sweep. The result is actually the same between sweep and without sweep, but with sweep we can make it easier. That's all.
Assalamualaikum. My name is Muhammad Syari bin Muhammad Zahir. Today I want to simulate the schematic diagram by using transient simulation. So first, we want to test and plot the graph of the resistance of R1, that is R is equal to 100 ohms. So as per in the lab sheet, we will change the value of R1 into 100 ohm, 150 ohm, and finally 200 ohms. After the simulation, we will get the graph. We will simulate the graph for voltage and for current. So by using this graph, we cannot get the precise value for the voltage and the current. So we use the tabular, and we will get the voltage and current value. So also, and we can see if we change the value of resistance, we will get the new value of the current. As we can see, the higher the value of the resistance, it will decrease the value of the current. So next, by using the transient simulation with the parametric sweep. So in the parametric sweep, we start with 100 ohm and stop to 200 ohms. And the transient simulation, we also use the set that is set in the part D. So as we can see here, this is the graph for the voltage and for current that we obtained. As we can see, the increase in the value of the resistor from R out is equal to 100 ohms to 200 ohms, we will get the decrease of the value of current. So by using this sweep parameter, it will make us easier to construct one circuit rather than to construct more than one, and we will get the same exact value. So these parameter sweeps help us in save our time and to get the precise value. Alright, that's from me.
For the difference between AC sweep and without sweep, with sweep we can go through R out with the same value without sweep. You can see here, For example, we have here is 150 ohm. So for the result without sweep is 1.6 and negative 1.6, and with sweep we have same value for 150, which is 1.6 and negative 1.6. And for example 2, for 200 ohm we have 1.2 and negative 1.2, and similarly for the sweep we have 1.2 and negative 1.2. But with sweep we can make it easier than without sweep, because we don't have to change resistance every time. It's similar to DC sweep, and with sweep we don't have to change resistance for every time. Which is R2 we change, but R1 we make it constant. But with sweep DC circuit, R1 we still constant, and R2 we make it R out. With sweep we don't have to change resistor each time to make it to simulate and get the different result. That's all. Okay, that's all from me. That's all from we from group 10.